Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at partial fraction decomposition where we have factors in the denominator that have exponents greater than 1. So here we've got 4x plus 7 over x plus 1 squared. And the way that we handle these factors that have exponents greater than 1 is we're going to break this up, We're going to break this up into one fraction that just has x plus 1 in the denominator, plus a second fraction that has x plus 1 squared in the denominator. We'll proceed just like we did with regular linear factors. So the only real difference is setting this up. If you had x plus 1 to the n power in your denominator, you would have to have one fraction with x plus 1 plus a second fraction with x plus 1 squared plus another fraction with x plus 1 cubed all the way out to one last fraction that has x plus 1 to the n power. And whatever letter we happen to be at that point. So in this example, we only have two fractions because the exponent was 2. In the next example, we'll do one that has 3. Try not to fast forward ahead to that one. I know it's exciting. Multiply through by the common denominator, which is x plus 1 squared. Let me write that down. The common denominator, x plus 1 squared. On the left side, we have 4x plus 7. On the right side, we've got a times x plus 1. One of the x plus 1s in x plus 1 squared divides out, but there's still going to be one left. And for b, they both divide out. So we've got a times x plus 1 plus b. So if we were going to substitute a value here for x, a good choice is -1, because at least we can make the term with a disappear. So x equals -1. That's 4 times -1 plus 7 equals b, equals a times -1 plus 1 plus b. This term is 0. On the right-hand side, on the left-hand side, -4 plus 7, that equals 3. All we have left on the right-hand side is b, so b equals 3. Halfway home. Now we can put in 3 for b here. Put in any other value of x that we want and solve. And so a good choice when you have a choice is x equals 0. 4 times 0 plus 7 equals a times 0 plus 1 plus b, which is now 3. The left-hand side is simply 7. The right-hand side is 1 times a, or just a, plus 3. And when we subtract away the 3, we find that a is equal to 4. So we've found the two numbers in the numerator that make this work. 4x plus 7 over x plus 1 squared equals 4 over x plus 1 plus 3 over x plus 1 squared. Let's try one more. This time we're going to use one that has a repeated factor whose exponent is 3. 2x squared minus 8x plus 9 over x plus 2 quantity cubed. Same approach as the last one. A over x minus 2, exponent 1, plus b over x minus 2 squared, exponent 2, plus c over x minus 2 cubed, exponent 3. And since that was the biggest power, that's where we stop. The common denominator is x minus 2 cubed. So we multiply both sides by that. On the left side, it completely divides out. And we're left with 2x squared minus 8x plus 9. On the right-hand side, x minus 2 divides out one time, but it leaves 2 with it. A times x minus 2 squared. Plus b, 2 of them divide out, one of them is going to be left, times x minus 2, plus c, they all divide out. Any ideas what you think we should try? Well, we should use x equals 2 here first. So if x equals 2, 2 times 2 squared minus 8 times 2 plus 9 equals a times 2 minus 2 squared, that's 0, plus b times 2 minus 2, that's 0, plus c. So really all we have left is c on the right-hand side. Whatever the left-hand side is, that's our value of c. This is 2 times 4 minus 16 plus 9, or 8 minus 16 plus 9. That all equals 1. So we know the value of c is 1. Now, let me recopy the equation, because we run into a dilemma that we haven't seen yet. 2x squared minus 8x plus 9 equals a times x minus 2 squared plus b times x minus 2 plus 1. We can't use 2 again because a and b are going to disappear. We've got to figure out how to solve for a and b. So what we're going to do here is we're going to create a system of equations, 2 equations with 2 unknowns, a and b. And we can do that by picking values to substitute in for x. And I'm going to start with x equals 1 to get my first equation. 2 times 1 squared minus 8 times 1 plus 9 equals a times 1 minus 2 squared plus b times 1 minus 2 plus 1. And we want to try to get this into general form for solving a system of equations. So on the left-hand side, that works out to be 3. It's 2 minus 8 plus 9. That's 3. On the right-hand side, 1 minus 2 is negative 1, but when we square it, it's positive 1. So that's a plus b times negative 1. We can write that as minus b plus 1. And if we subtract over the 1, this equation is really the same as a minus b equals 2. For the second equation, another convenient value to try is 0. 2 times 0 squared minus 8 times 0 plus 9 equals a times 0 minus 2 squared plus b times 0 minus 2 plus 1. The left side is 9. The right side, negative 2 squared is positive 4, so that's going to be 4a, negative 2 times b, so minus 2b plus 1. And if we get rid of the 1, subtract the 1 to the other side, we've got 4a minus 2b equals 8. So now I have a system of, oops, let's get a better color here. Not that one. Now I've got a system of 2 equations with 2 unknowns, a and b, and I can solve that. So now we're going back to an earlier section where we solve systems of linear equations. A minus b equals 2. 4a minus 2b equals 8. We could solve this pretty easily with substitution. We could get a or b isolated, but I'm going to use elimination. I'm going to multiply the top equation by negative 2. Negative 2a plus 2b equals negative 4, because now my b terms are opposites. Copy over the second one, 4a minus 2b equals 8. Add the 2 equations together. 2a equals 4, a equals 2. And then I can go back to either of those original equations, like a minus b equals 2, put in the 2 for a, and solve this. We find that b is equal to 0. So our three values in this solution, A is 2, B is 0, C is 1. So when we come back and look at this partial fraction decomposition at the top, A is 2, B was 0, and C was 1. So this middle term, we can basically avoid even writing it. So 2 over x minus 2 plus 1 over x minus 2 cubed. That is the partial fraction decomposition for 2x squared minus 8x plus 19 over x minus 2 cubed. Now again, when you have a repeated factor, you need to have a fraction that has that as a denominator to the first power, the second power, however many you have, you need a fraction for each one. All right, that's it for this one. You got a little preview of what we're going to take a look at next. See you then.